In this video, I'll describe what sampling distributions are and how they're related to samples. Let's start with a research question. You might have seen the headlines that sitting for too long can be dangerous for your health. Suppose you want to see how widespread this problem might be, so you decide to investigate how far people typically walk in a week. Ideally, we'd look at everybody in the entire population and count the number of steps they each took each day, and then take an average. But doing that would require more time and resources than any of us have. So instead of surveying the entire population, we look at a sample. Then you'd ask each person in the sample to each wear a pedometer, a device that counts their steps, for a week. At the end of the week, you record the total number of steps each person took. So we have these 10 numbers that make up the data for the sample, and we can look at the distribution of these data. This is called a distribution of the sample, and it has a sample mean of 56,889. Now let's go back to that population for a moment. What if, instead of our original sample, we had randomly selected a different group of 10 people? And you gave them pedometers, had them wear them for a week, and recorded all of the data. We could look at the distribution of these data, which would again be a distribution of a sample, and we could compute the mean. So now we have looked at two samples from the same population. Each sample had its own distribution of data, and each sample had its own mean. Now imagine for a moment that we kept repeating this process, starting with the population and repeatedly randomly selecting samples of 10 people. Each sample would have its own distribution and its own sample mean. Then we could think of this collection of sample means as a set of data itself. And we could look at the distribution of these sample means as a histogram. Now, let's think about exactly what this is showing us. We'll compare this distribution of sample means to the distribution of our first sample. The histogram on the left is a distribution of a sample. Each data point in this distribution is the number of steps taken by one person in the sample. In contrast, the distribution of sample averages is called a sampling distribution because it is generated by a process of repeated sampling. Each data point in this distribution is the mean number of steps taken by one 10-person sample. We regularly use sampling distributions in statistics to compute probabilities. For example, we could compute the probability of getting a sample with an average that was less than 50,900. Here it would be 2 out of the 16 sample averages. In statistics, we use sampling distributions to make inferences about population parameters, so it's important to understand what they are and how they're generated.